Hello! This video contains application of mathematics in the modern world through nature. So what is mathematics in the modern world? So according to the book that I read, mathematics in the modern world is about mathematics as a system of knowing or understanding our surroundings. It provides a glimpse into the nature of mathematics and how it is used to understand our world.
Nature of mathematics. In this video, we are focusing about patterns and numbers in nature. As rational creatures, we will more often than not distinguish and follow designs, whether deliberately or subliminally. Pattern recognition feels natural as of our brain is hardwired to do so. We even recognize the repeating interval of day and night, the rising and falling of tides, and the changing of the seasons.
So now, we are here to show you our understanding about mathematics in the modern world, the types of patterns with examples in nature.
Symmetry. Why it is called symmetry? I have something to share you why this thing called symmetry, and for you to understand also. Symm means from the word same, and metry means measure.
What is symmetry? Symmetry means that one shape is identical to the other shape when it's moved, rotates, or flipped.
There are three types of symmetry: the rotational symmetry, the reflective symmetry, and the translational symmetry.
One of the type of symmetry is rotational symmetry. Rotational symmetry is also known as radial symmetry in geometry, in the property of shape as when it looks like the same after rotation by a partial turn. One of the examples of rotational symmetry is wall fan. Wall fan has 4 blades. We can see that whenever the image rotates by 90 degrees, it gives the same image, so the image has rotational symmetry.
There are many examples of reflective symmetry in our nature. Reflective symmetry when one half of the object is identical to the other half of the object along the line through the center of the object. Examples of reflective symmetry in our nature are the human face. I point my face in and I cut it of the center of my face. Then you see that the right side is identical to the left side and the left side is identical to the right side, and or both sides are equal, and that is why it is example of reflective symmetry. Symmetry establishes pattern in designs by moving a specific object from one place to another and maintain the same size and the distance apart to each other. Example of translational symmetry is the tiles at the floor of my house.
What is fractals? Fractals is a never-ending pattern or a pattern that is infinitely complicated and self-similar across scales. They are made by repeatedly repeating a basic process in a continuous feedback loop. Because nature is full of fractals. Fractals are quite familiar to us.
For example, the tree from which the leaf field is full of fractals. If you look at a tree, you will see a shape that looks like a Y. This simple shape repeats itself within a branch, into another branch, and into the full shape of the tree.
Fractals can be found all around the world. The tree from which the leaf field, for example, it's full of fractals. When you look at the tree like this is the left field from the tree. You see a Y shaped, which is like this. Y shape. This simple shape is repeated within a branch into another branch and finally into the tree's whole shape.
Spiral pattern. A spiral pattern is a curved pattern that focuses on a center point and a series of circular shapes revolve around it. And hurricane is one of the examples of spiral pattern. Examples of spiral pattern. Example of spiral pattern is rose. Rose is a flower. It is a flower that contains a spiral pattern. Why? Because you can see it is circular shapes around it. That is why rose is one of the example of spiral pattern. The second one is a string of the ballpen. String of the ballpen contains circular shapes also. It is from the ballpen, inside the ballpen, so you can see if this observed properly. This is one of the examples of spiral pattern.
In mathematics, tessellation can be generalized to a higher dimensions and a variety of geometrics. A periodic tiling has a repeating patterns. Next is the regular tessellation. A regular tessellation is a pattern made by repeating a regular polygon. There are only 3 regular tessellations. First is the triangles, next is the square, and lastly is the hexagons.
A tessellation or tiling is the covering of a surface, often a plane using one or more geometric shapes called tiles, with no overlaps and gaps.
For example, a chessboard, it is square and uses 2 colors of squares, one light and one dark in a checkered pattern.
Wave pattern. Wave are disturbances that carries energy as they move. Wind waves are created as wind passes over a large body of water, creating patterns or ripples. When wind passes over land, it creates land dunes, and dunes form a range of pattern as well.
Fibonacci is a sequence generated by adding 2 previous numbers of the sequence. Fibonacci sequence were discovered by a man named Leonardo Pisa, the greatest European mathematician of the Middle Ages. He introduced the Arabic number system in Europe, born in 1170 and died in 1240. And this is the formula of Fibonacci sequence. One of the example here in nature is leaves, because when growing off the branch, Fibonacci can be viewed in their stems and veins. The more they grow, the higher the Fibonacci sequence is visible. Another example is tree. In tree, the Fibonacci begins in the growth of the trunk and then spiral outwards as the tree gets larger and taller.
Are some examples of Fibonacci sequence. The first one is the flower petals. The flower petals in an example of Fibonacci sequence because the number of petals in a flower consistently follow a Fibonacci sequence. Some flowers also like lily, buttercups, and daisy is also an example. The second one is the seed heads. The seed heads is an example of Fibonacci also because the head of a flower is a subject to a Fibonaccian processes. Typically, the seed heads are produced at the center and then migrate towards the outside to fill out the space. This plant is also example of Fibonacci sequence since, as you can see, each set of leaves spirals outwards.
Everything around you is numbers. Everything around you has patterns, and everything around you is mathematics.